Hello guys, I'm Nilam Panchal and in this video I'm going to discuss about the dilatant and rheopectic fluid. First of all, I like to give some introduction about rheology. It is a science dealing with the deformation and flow of matter. There are main two types of fluids, Newtonian and non-Newtonian fluid. Newtonian fluid gives us linear relation between stress and strain. Water, hydrocarbon, alcohol are the basic example of Newtonian fluid. Non-Newtonian fluid give non-linear relation between stress and strain. Mixture of corn flour and water, grease, paint, clay, ink, lubricants are the examples of non-Newtonian fluids. Dilatant fluid, it is a type of non-Newtonian fluid. It is also known as shear thickening fluid. Dilatant fluid's viscosity is increases as shear rate is increasing. We can make this fluid at home by making a 2 by 1 mixture of corn flour and water. It is a liquid, but when stirred it becomes thicker and more difficult to stir. If we will hit with a hammer, it will shatter like a brittle solid, but if left it will return to a liquid. Here it is a relationship between viscosity and shear rate of Newtonian and non-Newtonian fluid. It is a linear relation of Newtonian fluid. It is a behavior of dilatant fluid. As we increase the shear rate, shear stress is also increases. In pseudoplastic fluid, as we increase shear rate, viscosity is decreases or shear stress is decreases. We can use these fluids in body armor. There are some advantages like it provides more protection. Also by using this armor we can protect police from the gunshot and knife wounds, firefighters to mitigate damage done by explosion and falling objects. But there is one disadvantage. If slow moving object will not provide enough stress to make the dilatant fluid harden. There is a one video which is related to dilatant fluid, how we can make dilatant fluid at home, and there are some different experiment with the fluids. There is another non-Newtonian fluid, rheopectic fluid. Its viscosity increases as shear rate increases. Over time can become nearly solid if shear long enough. It demonstrates time-dependent increase in viscosity. The longer the fluid undergoes shearing force, the higher its viscosity. A good example of a rheopectic non-Newtonian fluid is a cream. If you stir cream just once, then nothing much will happen. However, keep stirring and it will be thickened. There are some examples of rheopectic fluid include gypsum, paste, printer, ink, lubricant, etc. It is a relationship between viscosity and shear rate time of rheopectic and thixotropic fluid. Here we can see that as we increase the shear rate as a time dependence, the also apparent viscosity is increasing, but at some point there is no much increase in viscosity where fluid become a solid. There are some applications of rheopectic fluid we can use in shock absorbance, military application, sporting goods and athletic footwear to skydiving, also in automobile safety. To conclude, this is the basic concept of dilatant and rheopectic fluid. Thank you for watching this video.